My name is Nick Bonus. This is my video for the ECT295 lab class. We built a digital compass with LED display. Here it is right here. Get it in there so you can see it a little better. I'll explain a little bit about it. We've got the pick down here underneath my finger. This is the microchip that controls everything. This is our LED display that shows the coordinates or arrows after the modification. And this up here, turn it sideways, this is the actual compass module. We've got our programming port right here on the back, and basically to start it off, first thing we did obviously was order the kit for the class. And when it came in, we inventory make sure all the parts were there, all the pieces, and then review the layout of how everything is supposed to go. Watch a video on how to insert the compass. I'm showing you the backside. Insert the compass into the board and solder the pins, which you can see here. This down here, this is the like the display pins, and then up here where it gets really close together, that is the compass module. So you can see on this board, this is my second one. I lost my dikes, so I couldn't cut really close to the board, so pretty much on all of my solders they stick out, or I trimmed them off a little bit what I could, but most of them I just bent and ensured that they wouldn't contact anything else, since I did misplace my dikes. So got everything inventoried, made sure it's all there, soldered the compass, ran through a wiring schematic provided in the class to ensure that the compass circuit is all fine. There's no bridges between the solders. On my second compass here, I had a small bridge on the compass module that I had to get rid of. Just flicked the solder off is all I did. My solder wick wasn't working very well, and I don't have a vacuum or anything for it. So solder the compass, make sure that's all fine, and then continue to solder the rest of the board, assemble it, solder it all. You got the various components, pick chip, power cord, all that stuff. Once all that's done, you can put the microchip in and make sure that it's working. It's supposed to have been pre-programmed. My second chip actually was, but my first one wasn't, so had to download the standard flow code file from the class, compile it to hex, and put it on here and make sure that everything was working fine. That all went fine. Couple issues I had was at first when I turned it on, obviously it didn't work, so I programmed it, but the first compass module, this one here, it doesn't work anymore. I threw the microchip away so I wouldn't try using it again, but I couldn't get it to read anything right away, so I tapped the compass a couple times and got it going, and then I noticed that on my display, a couple of the segments in the letters that it displays weren't showing up. So I found that I had a couple cold solder joints. I just had to reheat them and get the solder to flow in there better. Here's a video to show what the original compass did, and I'm going to show that to you now.
You need to pick it up. What? Your hand?
Yeah. Okay, you saw that. So that was the original, and then we modified it. The modifications included, I'm going to get this twisted and break it, but modifications included, you can see these jumper wires here. We had a couple of segments on the LED display that were not attached to an output on the PIC microchip. So we had to run some jumper wires to enable us to turn them on. And then after that, we were to modify the actual flow code program to light the correct segments. You enter a decimal value that corresponds to a binary value that is assigned to the different segments on the LED display. After that, I had a couple issues with that. Obviously, I have two. My first board, I had to pretty much ditch it because when I soldered my jumpers on, I got the wires too hot, and I ruined an output on the microchip. So luckily I had a second one that I was going to return but didn't. So I just went ahead and built a whole second compass. So what happened when I soldered it, I wish I could show it, but the second digit in the display was really dim, and I tried reseating the chip and re-flashing it, and it wouldn't work. So I ditched it, and then now that I've got it in my hand, some other troubleshooting I had to do on my first chip. I apparently was not thinking clearly. You can see that there is quite a bit of gap there for the programming jumper connector. I soldered it on the top side mistakenly, so I had to pull all the pins out individually and resolder it on the bottom. It didn't affect the programming at all. Once I got it all in there, everything was fine, but as far as it goes, it just looks bad. And then I had to resolder the battery cables a couple times from spinning it around and stuff like that. The solder gets in there and makes the wire stiff, and it eventually breaks off. So that's what I had to do with that. Some troubleshooting there. And then when I got my second one programmed, the only troubleshooting I really had to do with this one is redo some of my math on the outputs for the segments. I was on the chart, I misread it, and I was lighting, like for an arrow. I'll just show you how it's supposed to look here. Like on one of these, instead of being in a straight line the whole arrow, like this back segment was going vertical to the display instead of being straight with the arrow, so the arrow was essentially crooked and like it was turning the corner. Other than that, that's really all I had to do with this one, and you can see there it works just fine. The only thing is if you get the compass angled like this, it doesn't like to, it kind of gets stuck and it just doesn't respond very well. I was reading online about it, and it does say that it kind of floats in there, so it needs to remain vertical. But that's that. Let's see, some future improvements that I could make. Obviously would put it in a case, so the battery and stuff is all part of the unit. It's kind of a pain to hold the battery and the board on its own, and then on top of that there's the switch. It's not bad to do, but if you're in a real world situation, if you wanted to use it, it's kind of a pain to plug and unplug that jumper. Jumpers are not necessarily designed for switches that are used all the time. Another one, I guess, if you wanted to go crazy with it, would be to replace the LED display with the LCD display. So you could display, like, you know, on the left side here, you could display the direction you were going, and then, you know, you could add the temperature or the time too. You could add a clock or a temperature display with a temperature sensor. You probably have to replace the microchip too with a bigger one, but I've got some left over from other classes, and you know, it's something to fiddle with because I like soldering and building stuff, and flow code is fun to mess around in, so that would be a good update for me. And then I can, you know, make more use of it. In conclusion, this is a very, very fun project. Had a lot of fun soldering it and then resoldering it. I didn't really have a whole lot of trouble figuring it out. Like I said, I really enjoyed it. Flow code's fun. Soldering is good. This is just pretty cool little project to do for electronics. Always learn something new with it. Thank you.